But you can't do this to me. You know how much I sacrificed?
Hello guys, welcome to part 6 of our episode 1. Now that we understand isotopes, we can solve one more interesting mystery. Why do many elements in the periodic table have atomic masses that are not whole number? Take chlorine. Chlorine naturally exists mainly as two isotopes, chlorine 35 and chlorine 37. These isotopes are generally present in the nature in the approximation ratio 3:1. So imagine that we take a large collection of naturally occurring chlorine atoms. Most of them are chlorine 35, while a small number of them are chlorine 37. The atomic mass we see for chlorine in the periodic table is therefore not simply the mass of chlorine 35 or chlorine 37. It represents the average mass of naturally occurring mixture of its isotopes. This average takes into account both the masses of each isotope and its relative abundance. And there is only one very important point to remember. No individual chlorine atom has a mass of exactly 35.5 U. A particular chlorine atom is one isotope or another. The value around 35.5 U represents the weighted average of the naturally occurring chlorine. So chlorine isn't confused about its weight. We are averaging different chlorine atoms together. Quick calculation idea. For chlorine, the simplified 3:1 means that out of 4 atoms, approximately 3 are chlorine 35 and 1 is chlorine 37. So, the average can be visualized as average atomic mass is equal to 3 into 35 plus 1 into 37 plus divided by 4, which gives 35.5 U. That is why the periodic table gives us a decimal value rather than a whole number. So whenever you see a decimal atomic mass, remember it may be telling you the story of several naturally occurring isotopes being averaged together. Now let's put the idea of average atomic mass into practice. So here we have a numerical problem. We are given two isotopes of bromine with mass number 79 and bromine with mass number 81. With 79, it has 49.7% abundance and the other one has 50.3% abundance. The question is, what is the average atomic mass of bromine? Remember, we cannot simply take the ordinary average of 79 and 81 because the two isotopes are not present in exactly the same amount of ratio. We have to consider their percentage abundance. So, the formula is average atomic mass is equal to isotopic mass into fractional abundance. First, convert the percentage into fraction, that is 49.7% is equal to 0.497 and 50.3% is equal to 0.503. Now multiply each isotope's mass by its abundance, that is 79 into 49.7 plus 81 into 50.3. Therefore, average atomic mass of bromine is 80.006 U or approximately 80 atomic mass units. Notice something very interesting. The answer is very close to 80 U because the two isotopes are present in almost equal proportions. That is 49.7 and 50.3. So the key lesson is more abundant isotopes contribute more to the average. And remember, 80 atomic mass unit does not mean every bromine atom weighs 80 U. Individual atoms are still bromine 79 or bromine 81 in this simplified example. The value 80 atomic mass unit is the weighted average of the isotopic mixture.
Like, share, and subscribe to AkPhysics47.